Hello everyone. And welcome back once again to another interesting video. In today's video we'll discuss 10 advanced Python concepts to improve your Python skills. So if you are ready, let's start today's video. Introduction: Advanced Python Concepts. Python is an adaptable and powerful programming language recognized for its simplicity and clarity. As you progress in your journey of learning Python, it's crucial to grasp advanced concepts that can take your Python skills to the next level. Whether you're a beginner or an experienced developer, Python offers a wealth of opportunities to learn and create. Its simplicity, versatility, and enthusiastic community make it a language that continues to thrive and evolve. In this video, we'll explore 10 important advanced Python concepts that will help you further enhance your proficiency in the language. Let's dive in. How can I improve my Python skills? Improving your Python skills requires practice, determination, and a willingness to learn advanced concepts. Here are some approaches to help you enhance your Python skills. Build projects. Building projects is an effective way to apply your Python knowledge and gain hands-on experience. Contribute to open source. Contributing to open source projects allows you to work with experienced developers and learn best practices. Read Python books. There are numerous Python books available that delve into advanced concepts, which can expand your knowledge and understanding of the language. Attend Python events. Participating in Python conferences, meetups, and workshops provides opportunities to network with other Python enthusiasts and learn from experts in the field. Take online courses. Many online platforms offer advanced Python courses taught by industry professionals, allowing you to learn at your own pace. 10 most important concepts in Python. 1. Map function. The map function is a powerful tool in Python that applies a given function to each item of an iterable and returns an iterator. It eliminates the need for writing explicit loops and simplifies code readability. Using the map function can lead to cleaner and more concise code, especially when performing repetitive operations on lists, tuples, or other iterables. Understanding how to use the map function effectively can greatly improve your Python programming skills. 2. itertools. The itertools module is a collection of incredibly useful functions that provide efficient solutions to common problems encountered while working with iterators and iterable objects. It offers a wide range of functions, such as permutations, combinations, and infinite iterators, allowing you to manipulate and iterate over data structures efficiently. By familiarizing yourself with the itertools module, you'll gain a deeper understanding of Python's iterator ecosystem and unlock advanced techniques for solving complex problems. 3. Lambda function. Lambda functions, also known as anonymous functions, are single-line functions that do not have labels. They offer a concise way to write functions on the fly, making code more readable and compact. Understanding lambda functions and when to use them is crucial for writing expressive and efficient Python code. Through examples and practice, you can master the lambda function concept and use it to simplify your code base. 4. Exception handling. Exception handling allows you to gracefully handle errors and exceptions that occur during the execution of your Python program. By catching and handling exceptions, you can prevent your program from crashing and provide useful error messages for troubleshooting. Mastering exception handling techniques ensures your code is robust and can recover gracefully from unexpected situations. 5. Decorators. Decorators are a powerful Python feature that allows you to change the behavior of functions or classes without changing their source code. They offer you a neat and elegant approach to improving the functionality of existing programs. Understanding decorators and how to create and use them provides a valuable tool for code reuse and separation of concerns. 6. Collections. The collections module in Python provides additional data structures that extend the capabilities of built-in data types. It includes alternatives to traditional data structures like lists, tuples, and dictionaries. By utilizing the Collections module, you can solve more complex problems efficiently and maintain cleaner and more organized code. 7. Generators. Generators are a type of iterable in Python that generate values on the fly, as opposed to generating all values up front. They are memory efficient and suitable for handling large datasets or infinite sequences. Understanding generators and practicing their usage can greatly enhance your ability to work with large datasets and improve the performance of your Python programs. 8. Magic methods. Magic methods, also known as special methods or dunder methods, short for double underscore, allow you to redefine the behavior of built-in Python functions and operators. By leveraging magic methods, you can make your custom objects behave like built-in objects. Mastering magic methods empowers you to create more intuitive and powerful classes, enabling you to write elegant and Pythonic code. 9. Regular expressions. Regular expressions provide a powerful and expressive pattern matching mechanism in Python. By using a special syntax, you can search, match, and manipulate text-based data with precision and efficiency. Understanding regular expressions enables you to tackle complex text processing tasks and is essential for tasks such as data validation and text parsing. 10. Threading. Threading allows you to execute multiple threads concurrently within a single process. Python's threading module provides mechanisms for parallel execution, making it suitable for tasks that can benefit from concurrency. By mastering threading concepts in Python, you can optimize the performance of your programs and improve their responsiveness. Now, let's discuss what are the hardest concepts in Python. The difficulty of Python concepts varies from person to person, depending on their experience and familiarity with the language. However, some concepts are commonly considered more challenging. 1. Metaclasses. Metaclasses are classes that create classes. They introduce advanced concepts related to class creation and customization. 2. Closures. Closures involve nested functions that remember and access variables from their enclosing lexical scope, even when those functions are invoked outside their original context. 3. Concurrency. Python's support for both multithreading and multiprocessing introduces challenges related to synchronization, shared resources, and thread safety. 4. Memory management. Understanding Python's memory management, including concepts like reference counting and garbage collection, can be complex, especially for developers coming from languages with different memory models. 5. Decorators and metaprogramming. While decorators provide a concise and powerful way to modify behavior, they involve advanced metaprogramming concepts and can require a solid understanding of Python syntax and runtime model. Now let's see what topics are covered in Advanced Python. Advanced Python covers a wide range of topics beyond the basics, including functional programming techniques, design patterns, metaprogramming and reflection, concurrency and parallelism, data serialization and persistence, web development frameworks, networking and socket programming, GUI programming, data science and machine learning libraries. These topics allow you to build complex applications, optimize performance, and solve real-world problems using Python. What is most demanding in Python? Python is highly versatile, making it in demand for various specialized areas. Some of the most demanding areas in Python include web development. Python's simplicity and the availability of frameworks like Django and Flask make it popular for web development. Data science and machine learning. Python libraries like NumPy, Pandas, and TensorFlow make it the language of choice for data analysis and machine learning. Automation and scripting. Python is an excellent tool for process automation and developing scripts due to its simplicity of use and large standard library. DevOps and infrastructure. Python is widely used for infrastructure automation, configuration management, and cloud-related tasks. Cybersecurity. Python provides powerful libraries for tasks like ethical hacking, security testing, and malware analysis. Which is tough, Python or C++? Now let's discuss, which is tough, Python or C++. Determining which language is tougher, Python or C++, is subjective and depends on factors such as previous programming experience, personal preferences, and the specific goals of the programmer. Python is often considered more beginner-friendly due to its simplicity, readability, and extensive standard library. It focuses on ease of use and code readability, making it an excellent language for beginners. On the other hand, C++ is a low-level language with a steeper learning curve. It offers more control and direct access to hardware but with greater complexity and a larger language specification. Ultimately, the level of difficulty depends on your needs and objectives. Both Python and C++ have their strengths and challenges, and choosing the right language depends on the requirements of your project and your personal preferences. That's all for this video. If you found this video helpful, don't forget to subscribe, give it a thumbs up, and hit that notification bell for more content, so you don't miss any upcoming video. And, if you have any questions or topics you'd like us to cover in future videos, please let us know in the comments below. Until next time, keep exploring and keep coding. Thanks for watching, and happy coding.